Can you see the presentation online? Good, fantastic.
Yes.
Test, test, test. Can you hear me?
Yeah, you can now.
They can now, okay. So, yeah, Dr. Grace Hopper, she was a Rear Admiral in the US Navy, computer science at first, and she was actually one of the very first programmers in history. She was the inventor of the first linker, and I think we would all be totally screwed without those, so we can be truly grateful for that. And she set the foundations for the first high-level programming language. So I don't think any of us would be doing what we are doing here right now without basically her contributions to our field. So truly inspiring in my opinion. So Abaco Systems, I'm keeping that quite short. Basically, we are a defense company. We are supplying to the military and aero market. So we are creating ruggedized computer systems for any kind of applications, be it from jet planes to ground vehicles or so. So we are supplying to the people that actually then make the end product for the military. Part of what we are doing is that we are testing our products in quite harsh environments. So there is some qualification obviously going on with vibration. Not every unit is necessarily going to get vibrated, but every unit that we are testing is getting tested to the temperature specifications that we are guaranteeing those units to work. So which can be quite challenging. So that's basically what we are doing, and our team in particular has been automating this process, has been streamlining it, increasing throughput, allowing for basically parallel testing to go on, and that's so that's what we are doing. So we're talking about parallel and batch testing. So that's what the title says. And I just forget that I kind of forgot to make the biggest type of advertisement for our company. We are a center of excellence. So we have actually, we've gone through the whole auditing process last year in August, and we have been the first company in the UK which has managed to become a NI Center of Excellence. So all our processes have been audited, the code quality has been audited, basically the process from start to finish. And so, yeah, that is actually, which means really, truly, you should have put like these COE icon next to all of us.
Okay.
Just kidding, just kidding.
No, I shouldn't do it.
But yeah, so that was one of our big achievements in 2019. So we like to go on about it.
Did you say you're the first in the UK?
Yes, the first of the UK. If you haven't heard it yet, we are the first in the UK that has managed to, we actually beat quite some tough competition. I know JLR have been working on it for quite a while, so that was quite sweet. Right, okay. When we're talking about parallel and batch processing, parallel and batch testing, what we're really talking about is actually what type of process model we are going to use when executing our TestStand sequences. TestStand itself is nothing but an engine. So everything, basically all test execution which happens on top of that is kind of user-defined, even though these process models come actually directly from National Instruments unless you decide to modify them. There are 3 of them which come shipped with TestStand, which is the sequential process model, which is by default activated when you install TestStand. It's probably, if you've used TestStand before, that is what you're all used to. Now there is the parallel process model, which allows you to test multiple units completely independent from another. So there is always going to be a window open where you can just say, like, you start off unit number 1, and while this is running, you can just basically add unit number 2 and start that off, wait an hour and add unit number 3. And while unit number 1 is finished, you can exchange that, and so on. So that is being really useful if you have a setup where there is complete independence between those units. That doesn't necessarily mean that it can't use the same test equipment, But generally, there shouldn't be any kind of confinement which forces the units to work together. Now, we have this confinement. All our units need to be tested to temperature. So all of them are in a chamber, so which means our confinement there, basically our restriction there is that we need to ensure that basically all these units are synchronized to the actual temperature set points. And that's where the batch process model comes in. So you have multiple units, you kick them off all at the same time, and then they run through and they synchronize through at various places, depending how you actually develop that. So let's go through actually how do you actually change the process model. So in case you've never opened TestStand before, so the sequential model, basically I've already talked about this. So how do I change the process model? There are two ways of doing that. The one is you change it globally. That means basically every sequence by default is going to use the setting in the is going to use that setting, and that is in configure station options, and then on the model tab you can change the process model. The other way is that you can change it in the sequence itself. So if you go, you have your sequence open, you go on Edit, Sequence File Properties, and then you can under Advanced can select a model file. So you first need to select under model option require specific model, and then you can select the model. Normally there are only three. I don't know if there's one which comes with a framework now, Jenkins, or is that just? I think that's just some messing around that I've done. Yeah, that's just me. You won't get the Jenkins one. Doesn't come with this presentation either, I'm afraid. Right, don't forget when you set that up to also set the number of the test sockets, otherwise it's just going to default to 2, I think. Is it 4? 4, which is quite annoying because that's normally not how many you've got to begin with. Right, you can also, what is also quite nice is you have this tile execution windows. So that is a setting where each of the executions in the sequence editor is going to get its own tile. Now, if you have like 8 executions going on, you will have 8 pretty tiny tiles, and you won't be able to see anything. Untick that, and there is only going to be 1 tile, and you can basically click through the different executions then. So that's just one to keep in mind. If you're wondering basically, why is this looking so stupid? That's why. Right, now multitasking, there are various difficulties. So the difficulties which I've kind of picked out here is the synchronization of sockets for different parts of the test. That is something which is mostly necessary for batch, because in parallel, the units are generally executing independently. Then synchronizing of multi-threaded tests. So that is basically, I will go through like an example where we have a watchdog thread, which is basically running in the background and is going to check if our hardware is within acceptable safety limits. And if not, it's basically just going to cut everything out. Because the worst case scenario that we have in our testing is that we can't hold the temperature set point in the oven. Our ovens or environmental chambers are obviously heated by electricity and they're cooled by liquid nitrogen. And it has happened more than once that the liquid nitrogen has run out. And even if the unit is idle in those environmental chambers, they are so well insulated that even if you only have 5 watts going in there, go back 24 hours later and you have basically the whole everything cooking at like 120 degrees. So that is why kind of at that stage, if we see something is happening, we just cut off all electricity, which means it's at least not heating up any further. So I'm going through an example there, how you can synchronize that, how you can deal with that. How do you share data between those? So for example, in that example, if something happens there in this asynchronous thread, you want to share that with all the test sockets, so that is kind of like in your test report, that you basically know like all of these have failed. They haven't really failed, It's basically just a malfunction of the test equipment. Shared equipment, how do you deal with that? So an example would be, obviously, you could have a shared oscilloscope. What we have quite often is that we have our UUTs, we don't do this low-level testing where we actually go like flying probe measurements or something like that. What we rather do is that our units are basically single-board computers, and we have test scripts running on them, and we are interfacing with the unit and interrogating, like, how's this test going, basically kicking off the next test, and then evaluating if it's actually all going well or not. That means that we aren't really dealing with this kind of problem that we have to share any kind of real measurement equipment between our units. What we rather have is, for example, we have 4 units, and we want to test the Ethernet port on all of those units. All of those units are connected to a switch, which is then connected to, for example, like an iPerf server, and we run traffic basically to that server and back. But if all units would do that at the same time, the throughput would only be a quarter of what we actually expect to see. So that would be an automatic reject. So that's where kind of like this switch is kind of like a virtual shared resource, which we really need to ring fence to make sure that the tests are passing. Terminating is a big problem. How do you do that? Don't do terminate all, just kind of as a spoiler. We'll get to that. And kind of going with that is also the error handling. So the synchronization of sockets. You've got, as LabVIEW engineers, you will be familiar with, well, definitely with queue and notifications. You can use rendezvous as well. They work as well. I haven't really found that much use for them, or probably worked around it, because I just have never really used them. So this is mainly applicable for batch processing. Now there are specialized synchronization structures, these batch synchronizations, and you can just basically set those to start one, like enter, and then you can set them to a parallel, which means all of the units will basically come to this batch synchronization entry step, and will wait until all the sockets are there. So that makes also sure that everything is actually synchronized, is running in parallel from that point. And then they go in parallel basically through what is coming. The other thing is that you can set it to is run it sequentially, which means then it's running one at a time, or you can set it to only run one thread. So for example, if you have this example of this watchdog, which I talked about earlier, you probably only want to run this on one thread, and then have communication structures in place to make sure that this information is spread throughout all the other test sockets. Of doing that is using the step properties. In the step properties, there is a synchronization place, and then you can set the batch synchronization to, again, parallel, sequentially, only one is executing. And then you will get in the step list, you will just get this this little node there, batch. So that kind of comes to the advantages and disadvantages. This step type is really nice for code readability. You can see, like, right, okay, this is where my synchronization structure is starting, and this is where it's ending. If there is anything in there which can fail and can cause a termination, you are screwed. Because it is just going to bomb out of there, it's going to, basically going back here, it's going to bypass the exit, which means the other units which are waiting patiently at the enter step are basically just, yeah, that synchronization structure is not going to get released. The one thread which basically got through there, bombed out, probably terminates and comes to the, basically ends the execution. And at that stage, this synchronization structure is just going to throw an error, basically saying like, well, this hasn't been properly closed down, and everything just falls to pieces. So that's the really, really bad thing about that, which is the advantage of the other one. While the code is kind of obfuscated, I really don't like this. Basically, there's just this little batch thing there in the corner, and if you're unlucky, you're not even displaying that column. But it is safe against any kind of terminations. So whenever you have like a longer list of steps that you need to synchronize, the general recommendation is put that into a subsequence and then put in the step properties the synchronization on there, and all your woes should go away. Synchronizing multi-threaded tests. I have already, basically already given a little bit of an introduction to this. So, for example, like we want to check like overcurrents, temperature, that type of stuff. But how do we actually shut this down now? Because we generally just fire it off as like a basically fire and forget, and want it only to act if it actually does something. If it needs to do something. So there are two ways. The one way which I know Adam is definitely preferring, which is the clean way, where you actually put some kind of notification in there. So you call the sequence asynchronously. You can see it's basically called there in a new thread. And we send a notifier once we want this to shut down. And then we have in the actual subsequence, we have an infinite while loop, basically infinite. And then the notifier is actually going to set this locals abort flag, which is then going to shut everything down. So I prefer the dirty way. The dirty way is that you don't set the call sequence to in new thread, but actually you put it to new execution. You don't use a process model, and you store your execution reference. And then when you are done with it, you simply terminate it. Already, I see there should be, at the end of the terminate, should be 2 brackets. This is not going to work, but there we go. Slight syntax error. But that's kind of that way. In particular, if you don't want the results of the subsequence, if you want the results of that subsequence, do it the clean way, because if you do it this way, the results of the subsequence will come back as terminated. Now, how do you actually deal with data from asynchronous calls? So the data is retrieved by a wait step. So in this case, I'm still using my new execution. I could also be using the new thread run base, and in the wait you can then set it to wait for an execution to end, and it's just basically waiting for my call sequence to end. Now the wait step is actually going to have the pass-fail information from the asynchronous subsequence, and then basically, dependent on as a sub items basically of this wait step, you will then get the items of the steps which actually executed in the subsequence. So that means they are not in chronological order, which can be very, very confusing when you run it for the first time. Just be aware of that. The reporting is not aware of anything which is running asynchronously in a different thread or execution until it gets collected by the main thread as part of a wait. Sharing data. Don't use global variables to share data between sockets. I'm showing you anyway how to do it. You go to edit sequence file properties, and by default, the sequence file globals are not actually shared between the different executions of different test sockets. So you can set that there to all executions share the same file globals. Don't, unless you have a good reason to do so. So for example, we have like a plugin which is kind of running what would normally be the modifications in a modified process model. So we've, to a large extent, got around modifying our process model. I think we have now modified it. We caved in. But to a large extent, we were able to avoid it. Generally, if you don't have to modify your process model, don't, because it means you have to maintain it when TestStand updates. There has been like a big change in process model. I think was it 2012? That's what it was. Yeah, in 2012, there's been a really big change in the process model. In particular, it introduced those plugins now. And I don't expect there big changes to come along anytime soon, but if it does, you will basically have to reapply all your changes. While with the plugins, they should pound into the swear jar. They should just carry over. And there basically I had to share information between different executions, not necessarily different test sockets. The problem is that each entry point in the plugin is called in a separate execution, and otherwise I was not able to actually share any kind of data between the different entry points in the plugin, which I needed to do. So the better way is using notifiers and queues. So I've already given like an example with the asynchronous sequence, but that can also be obviously widened out to doing communication to other test sockets. Shared equipment. So for one piece of equipment, you can just use a lock. So that's quite simple. You create a lock. In this case, it's a measuring tool. Then you actually lock the device and use the device for whatever you need to do, and then you unlock it again. And that means basically that all the sockets will wait at the lock. They're not synchronizing at that point, but they will wait basically until the device is available, and then we'll execute the code which is between the lock and the unlock. Yeah, the unlock is basically early unlock in the as one of the options, because otherwise it would just automatically unlock kind of with the lifetime of the lock, which can be various things. So that's configurable. No, come on. Doesn't like me anymore. No. Oh well. No, it's the computer. It's the computer. Well, there we go. There we go. Right. Let me just see if shared equipment. Right. Okay. Right. Let me just see. Is this working? Yeah, this is working now again. So the other thing is, if you have multiple devices, you can try auto scheduling. I can show an example if we've got time by the end of this. I can quickly show an example of that. What you basically do there is you have multiple sockets which all have to access certain devices in a basically in the order is not necessarily important. I mean, if it is important, then you have to, for example, use a lock or something like that. But if it's not important, then this auto scheduling is simply going to just see like, oh, which one of those devices is free right now? Yeah, socket 1, you can go ahead and do this. Socket 2, you do that, and that way you can basically you can go around and try to use your instruments in a slightly more optimal way. It's not necessarily perfect. In particular, when the timing can be just wrong, that it just decides that something. Yeah, basically, when it enters the auto scheduling, it basically just assigns which socket is going to do which measurement. So, for example, we have 3 sockets, and it basically decides socket or 2 sockets or something like that, and it now decides that we need at least 3 sockets, right? Okay. Socket 1 and 2 are basically going through the measurement right now. And socket 3 is basically just going to get assigned one of those. Now, for example, socket 3 now waits for measurement 1 to continue, but it's not kind of re-evaluating this, the status. So what happens now is socket 3 is waiting for measurement 1 to finish, which is only like a minute out of 20 minutes in. Well, the measurement 2 is actually just finishing. So measurement device 2 is now available, but socket 3 is just going to wait the 20 minutes out for measurement 1 to become available, and then it is going to do measurement 2. So it's not perfect, but it might be better than nothing.
Another issue with that is your reporting can be different.
Yes, yes, that is right. Like in particular for database entries or something like that, that can be quite annoying. Right, termination. Terminate all is really, really bad. Don't use it. Don't use it. In particular, I mean, if you use it in sequential, I don't care, and I don't think TestStand cares. What basically happens is when a multi-test launches, you have X amounts of executions opening, where one of them is a controller. Now, you've always wondered where the rainbow ends with a nice big chest of gold that is in the controller thread. And if you kill this controller thread, you are literally killing rainbows. Please don't do this. So it basically means you might as well just unplug your computer. You're losing everything. It's basically all dead if you do terminate all. Instead, you have to be a little bit cleverer. And so there's like a little code snippet there at the bottom. You have to go through the number of test sockets. I think the controller is always on test socket number -1. And so basically you just count up from the test socket number from 0 to that number and terminate those sockets individually. That way, your controller thread is still alive and you can actually normally continue. You could then cleanly shut down everything, which means the results reporting is going to actually work. Otherwise, you literally lose everything. It's I think the results reporting is not necessarily going to return anything then. In particular, if you don't have on-the-fly reporting. Well, this way, it's basically everything is actually going to work normally. So just create yourself a sequence, and rather than saying like, do a terminate all, just do that. Really, you're going to thank me later, and the rainbows like it as well. So, and then the final thing is, you would really like the functionality of a termination, as in it's just going through the cleanup stages of all the nested sequences, and then basically just going to the end. But you don't necessarily want it to show as terminated. So that's actually this termination bluff. The name comes from me. Basically Adam has come up with the idea. It's probably on some forum or so. Ray has probably done it years ago. I wouldn't be. I think I saw something about it. I think you did actually post it on the thread. Okay. The idea is that you actually terminate the sequence where you want to go through the functionality of the termination, but then you actually cancel the termination right before the end. So which means you've gone all the way to the end. You've had the nice functionality of the termination, as in it's not trying to execute anything which is not necessary anymore. It's really just cleaning everything up so that you can come to to basically the end of a clean execution rather than everything becoming really messy. And then you just cancel the termination, and it will just take the state, the pass-fail state that it was in, or error state that it was in beforehand. So, and that is, the termination bluff. So, and with that said, I think I'm actually rather early. Yeah, are there any questions? Or in that case, I'll just quickly go through this example. Can you see that?
Yeah.
Fantastic. Right.
That's the problem.
Yeah.
Do you want to turn around?
No, I'm not giving up here. This would be defeat. Right. Okay. So I need to go to the public. I could have probably. Well, whatever. I'm causing myself more pain than necessary. My neck is hurting. Right, examples. Is it in parallel testing, possibly? Comparing these, yeah. Right. Right, okay. So another help, or don't know, I wouldn't necessarily call it a helpful tool. It's a nice gimmick. You have here in tools, you have the profile execution. Can you see that?
Yeah.
Fantastic. So if we start this now, why is this? Oh, we haven't actually. Oh, yeah, it's just it's selecting the process model on the fly. So if we just start this, no, and we get the. Oh, there's the profile. I even started that automatically, I think. So we can see here. Well, you see the problem here with the tiled windows in the background. That's what I meant. So here we are going through sequentially. Every socket is basically doing everything sequentially, which obviously, if that's what needs to be done, it's taking a lot of time. Now.
Yeah, it's done the DMM test, and that was good.
Yeah. Oh, okay. Yeah. Oh, yeah. Obviously needs more hardware. So now the parallel testing. So yeah, basically the first one has done the DMM testing and is relieving or is relinquishing that control, and then the next one is going over. And you can see that's not very efficient at all. It means there is only the first few execution. There's basically only there's nothing executing there. So now it's the auto scheduling. So it immediately sees like, oh, there is the scope and DMM is available, and it's just trying to be a little bit more clever about it. Yeah, basically the time saving is actually quite significant. Yeah, so, and it was limited by the DMM execution, but basically 4 times the DMM execution gave us then, in the end, the execution time of that. So, but what I meant was basically I had it before that I basically had it, if in this example, I would have had 5 times the execution time of the DMM, because one time it was just basically waiting for the wrong thing. Right, what are we doing next? It's still auto scheduling.
Yeah, this is with an extra hardware.
Okay,
So
more hardware. And you see the more hardware you actually add, the more efficient it gets. So basically there, it's what it did there. What's interesting here is you can see there is now DMM1 and DMM2, and those are kind of the same type of resource. So it is looking which one is available. It's obviously only going to execute the DMM test once, but depending on which one is available. So that really brought down the time. So that's kind of like the auto scheduling.
So there's a summary thing as well in the time that in the bottom list there.
Oh yeah.
So if you expand it, just in case you were interested. And also I want to make your life difficult.
Okay.
You have to turn around, right?
Yeah.
No, so yeah, it shows the duration. If you like. So. Yeah,
you can generally see like obviously the individual executions, but also the overarching synchronization structure. So you get direct measurement and direct metrics basically out of there, how efficient your test is executing or not. But yeah, as I said, it's better than nothing, and it's probably much simpler than trying to do your own thing. So yeah, they have put a lot of thought in there. They could put 5% more thought into it, I think, to make it really good. But yeah, it is a good tool. You definitely should use it if you've got an application for it. Right, are there any more questions? In that case, thank you very much for listening. And I think it's Michael's turn, isn't it?
yeah.
Yeah. Thank you.